Okay, looks like not many people are interested. It's fine. Let us wait till 4 5 uh, and see how many are planning to come. Okay, good evening. I think there are not too many people who are going to come. So let us start. Uh, okay. Okay. So this is week 9, and uh, as you know, the overall idea has been that we'll cover some aspect of UML and then some aspect of system building in each week, in each of the last 4 weeks. So we've already had a look at UML in some sense. We know that what class diagrams do. We also know that these so-called state diagrams, they are diagrams that are basically applicable for a single object. Okay, so whenever you want to show how an object changes its state over a period of time, the diagram that can help you in doing that is the state diagram. Now, one of the issue with with the state diagram is that it is pretty much focused only on one aspect of your system, because it is only talking about one object at a time. Now, if you want to see a broader picture, if you want to see what are the other objects doing while this particular object was being changed, that you cannot straight away understand from state diagram. Maybe you can put together multiple state diagrams and then try to figure it out, but straight away you cannot figure it out right from just one state diagram. So in order to understand the broader picture, in order to communicate a broader picture about systems behavior, what you can do is you can use a sequence diagram. So a sequence diagram is actually a diagram that can be made to look extremely complicated. Let me say this out aloud. Sometimes you might see sequence diagrams that are probably beat the purpose that they were supposed to solve, right? I mean, the purpose of a diagram should be that you don't have to read anything. You can simply see the diagram and understand. But sometimes these sequence diagrams get so cluttered and so complicated that it becomes difficult to understand. So we are not really going to look at all the aspects of a sequence diagram. There are so many things that can be done in a sequence diagram, but we are only going to focus on the most primitive things for which state diagrams should, and in my view, must be used. So let us start with that part. So to understand what a state diagram does, the first thing that you need to know is it actually shows the temporal understanding of the system. So when I say temporal, it means there are events that are happening in real time, and you want to piece them together on a timeline. You need to understand when exactly did a particular event occurred with respect to another event. Please keep this in mind, that with respect to is an important aspect here. So in a particular sequence diagram, we are going to discuss only certain things. For example, we are going to only talk about interactions between objects. But a sequence diagram can have multiple aspects. One of the things that it can show is an actor. We'll discuss what an actor is once we discuss the use case diagrams. But this is just to give you an idea that sequence diagrams can have actors. What are actors? We'll just discuss in about 5 minutes of time. So for now, the sequence diagram that we are going to look at, the only thing that these sequence diagrams are going to have are objects. And what really is this sequence diagram going to show? It is going to show interactions between these objects. So the first thing you need to know is that a sequence diagram looks slightly different from a state diagram. So in a sequence diagram, you have horizontal elements and vertical elements. Okay, the vertical elements basically represent one object. It could be an actor as well, but for now, for our purpose, we are going to assume they are objects. So one particular vertical element means one particular object, and the horizontal elements are essentially the interactions between the objects. Okay, so this is an example of how an object looks like in a sequence diagram. So you write the type of the object and the name of the object. Keep in mind that you can have two different objects of the same type as well. Okay, so it is possible to have such a scenario, but this is the idea that you whichever important operations, whichever important objects do you have in your system, you can represent them like this: a box in which you write the name of the object, and then this dotted line. This dotted line, okay, it is known as the lifeline. So essentially what we are trying to show here is something like this. You know that a state diagram tells you exactly when does the state of an object change. Okay, it happens when there is some relevant event. Otherwise the state of the object basically remains constant, right? So there will be only probably a short amount of time when the state changes, and then the state remains exactly the same for rest of the time. So this lifeline that we draw, this dotted line, the idea is to show the complete life cycle of the application, the complete timeline of the application. And within this timeline, only when there is going to be an interaction, there is going to be a change in something that we want to show within the diagram, we are going to add an activation over this dotted line. Okay, an activation is basically a filled um, thin rectangle, and the horizontal elements that we wanted to show basically run from one activation to another activation. There can also be cases where it is a self activation, so in which case you show a self loop. So self loops are essentially events which are internal to one object. Okay, they are not something that concerns any other object. So that is also possible to show in a sequence diagram. But whenever you want to show that a particular event has occurred, and this event originated because of the processing that was going on in a particular object, you can show it using an interaction. There are two ways to show interactions that we are going to use. There are others as well. So one is a signal. A signal is a one-way arrow. One-way arrow, as in it says that something has happened with object X, and it wants to tell this to object Y. Okay. The other thing that you might do, the other type of interaction that you might see between two objects, is the concept of call and return. So there is an object. Well, let us say you called an operation associated with an object. Let us say it's called func. So within the func function, you are executing, and there you have an object of another type. There you call the other type object dot func2, something like this. So this you can do, this is possible. And if you want to show this in a sequence diagram, this is the way to do that. You basically show a call and then a return. The return arrow is dotted. The call arrow is solid. The arrow ends are also different, slightly different. This is a different type of arrow, and this is a different type of arrow. And this is a self call. A self call basically means that this event is something that originated within this object, and it is being consumed within this object as well. One of the things that you have to understand is that because we are showing temporal nature, it means that when you go from top to bottom, the this particular sequence diagram actually shows a sequence. That means whatever is on top happens before, and whatever is on the bottom happens later. So for example, you first make a call, and then the call returns. Similarly, this call is going to take place before this call. So it only shows you the relative ordering between these interactions. It doesn't actually show you the amount of time that will be taken. Okay, so these things are not to scale. That is the idea. The only thing that they show is that this interaction happens before this interaction. So till now whatever we have discussed, okay, the state diagrams and the sequence diagrams, sequence diagram in some way are basically system wide. If not system wide, at least they talk about interactions between multiple objects. State diagrams were basically for just one particular object. Now if we want to go a step back and we want to provide some information about the system at the system level, okay, we are not going down, but just at the system level. So what are the things that we'll have to communicate? So as a system, any system will have certain functionalities, right? You are supposed to cater to whatever it was expected. If you remember, right from day one, whenever we started with our projects, I've been telling you that you will have to write down all the requirements for your project, right? So why? Because in the beginning you only see a system as a collection of functionalities. You don't really care how many classes are going to be used and how many objects will be there. You look at as a collection of use cases. This is the term. Okay, so a use case is essentially loosely a requirement suggested to you by the user, but it is well articulated. Okay, well articulated as in the user comes to your the user comes to your system's interface. The user provides these kind of inputs. Then this is what the user expects. Of course, a use case has to be from the user's perspective. It is not from your perspective, but from the perspective of the user. So a typical use case could be the user logs into the internet banking site of your bank, and then asks you to issue a new ATM. Okay, so this is the expectations from the system, but from the perspective of user. It from the perspective of a developer, you will say, okay, I'll need to have a class which can capture this request, and then maybe this particular request object will have to communicate with the database, do this, do that, whatever it is, right? So from the developer's perspective, you talk about implementation. From the user's perspective, you talk about use cases. So if you want to show what are the different use cases that your system has, and at the same time you want to show what are the associated actors with your system. So who is an actor? Actor is any entity which is going to be interact which is going to interact with your system, but it is not a part of the system. So the classic example here is again your user. Your user is an actor for your system, right? The user is not a part of the system, but the he or she is going to interact with your system. Another example is, let us say there is a person who's going to maintain your code. Okay, for example, if you've built a website, there may be a database administrator who is going to use your website to do certain tasks or whatever it is, right? So there are number of there could be a number of actors which are not directly a part of your system, but they do interact with your system. These are known as actors. So a use case diagram describes the relationship of your system with its actors. And to be precise, it actually breaks down the whole system into a collection of use cases, and then it shows what use cases are essentially associated with what actors. So a typical example is something like this. In this system, I'm showing two actors and three use cases, and then I'm showing their associations with the use cases. A typical example could be that customer as well as the administrator of the bank are two actors. This is my banking website. The user has a use case, create a service request, whereas the administrator has a use case, approve a service request from a customer, right? So they are both they are both going to interact with your system. The use cases, the expectations from the system might be different. So a use case diagram depicts this, that at a system level, who are going to be your target audiences, who are going to be the people who are going to interact with your system, and what exactly are the relevant aspects of your system that are associated with them. So there is one more interaction diagram before we finish off the interaction modeling part. So till now, what are the things that you know that that a class diagram can be used to show the structure of your system using different types of classes. The state diagram can show the changes in the state of a particular object as and when there are some events. A sequence diagram can show you a kind of temporal behavior on a timeline where you can see what event occurs when. Now, uh, 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 an activity diagram is in some ways a different kind of diagram altogether. Okay, an activity diagram is very similar to a flow chart, right? And the reason why sometimes people actually want to create an activity diagram is because in certain scenarios you are only interested in knowing the operations that your system performs and not really the data that is used. Okay, so for example, if there's a person who's going to be a user, like going back to the example of a bank. Let us say the bank's administrator, that person will not really be interested in knowing much about your objects and their states, right? The bank manager, for example, would like to know the complete process by which a service request can be approved, right? So he or she would say, okay, just tell me, what are the things I am supposed to do. So you'll say, okay, you have to go to this portal, you have to click here, then you have to put your login details. After logging in, you have to go to this dashboard, you have to click here, then there may be an authorization, then you do this, you do that. So basically there is a process, right? There are there are a number of steps or a number of operations that are going to be performed in this process. And if you just want to depict this part of your system, this behavior of your system, then you can use something like an activity diagram. An activity diagram, as I said, looks very similar to a flowchart. It has elements which are known as activities. So each step that I talked about right now is considered as an activity, and there are elements with the help of which you can provide some kind of conditions. So you say, if the person who is trying to approve the service request is authorized, do this. If he or she is not authorized, do that. So there is a kind of branching here. And similarly, there can be certain things that are supposed to go on in parallel. So you can say that you can approve multiple requests and in one go, right? And then basically these requests start getting approved in parallel. So there are parallelism indicators, there are branching elements in an activity diagram. It looks very similar to a flowchart. And another thing is that any particular activity can be dissected as in, you can say that this is actually a very complex activity, so let me break it down further to a different level. And you can basically say this activity has the following sub activities, and this is how these sub activities are performed. And sometimes the term used for these sub activities is action. So you say that this activity consists of these actions, and these actions happen in this particular order. So this is an example of how an activity diagram looks like. You, by the way, can use a start state and an end state similar to a state diagram, because usually you try to show one complete end to end picture of your system's usage. This is why you have the start and end buttons, right? So this is why often activity diagrams are directly related to use cases. So you create one activity diagram for each use case that you have. Okay, so this is a common thing to do. And here you can see this is the bifurcation element where there is a condition. If the condition is true, this activity is performed. If the condition is false, this activity is performed. And then this is a merging node. So from here onwards, whether you come from here or you come from here, you go here. And this is how you break it down. When you have a more complex activity, you can break it down into actions. These are the actions here, and these are those parallelism indicators. So basically what this really means is that there is a fork here. Fork, we'll actually come to know about fork and joint uh, later, in the next week's lecture. But the idea is that from here onwards, these two activities are executing in parallel, and then after these two activities have finished, they again merge together. So this is a join in the computation, and then from there onwards things go in a straight line fashion. Any queries? Don't worry. You do have the lectures on YouTube, so you can go and have a look at them later as well. But if anything struck your mind and you would like me to explain that, I can do that. Okay, so in a nutshell, whenever you are going to start doing this interaction modeling for your system, there are certain things that you should try to do, right? The first thing that you should do is think about the use cases of your system, and then maybe drawing a use case diagram. The next thing could be trying to figure out how these things can be achieved. These use cases, how can they be achieved? So maybe the next step could be to start with the class diagrams and state diagrams, and then once you have these, when you want to show how different objects interact with each other, you can pick a sequence diagram. An activity diagram is, as I said, it is a completely different perspective of the system. It is still linked. It has to, there has to be coherence between the other diagrams and activity diagram, but activity diagrams are, as I said, they are only important if you want to provide a operations based perspective of your system rather than a data based perspective. Okay, any questions, or shall we move on to the system building skill for this week? Okay, so different weeks we have seen different system building skills. So for this week, the skill is UI design, GUI design. Let me share this. Okay, and let me also make this clear that whenever I talk about UI design, I am not talking about things like HTML and CSS and all that stuff. No, that is not what I'm talking about. I'm talking about building window applications and how you put these kind of widgets within a window application. So whatever we are going to discuss, that is mostly mostly applicable for window applications. I don't know whether there are any similarities of this with web development, but we are only going to talk about designing UIs in the form of native window applications. So whenever you want to create a native application, the first thing that you do is you whatever UI toolkit you are using, you have to figure out how to create a window, how to create a main window. Okay, this main window is basically a container where everything else of your application is going to go and sit. So the first thing is you create a main window. Now there could be other windows as well in your system. There could be some kind of secondary windows which are attached to the main window, and the main window essentially has logic to spawn these secondary windows. But the idea is something like this: these so-called secondary windows can either be modal or non-modal. These two terms are very common in the UI domain. What it really means is something like this. Let us say you have a web page, okay, and the web page displays an alert to you. So you know that if I'm not wrong, until you click on that OK within the alert, you will not be allowed to go back and interact with the web page. If I'm not wrong, that is exactly what happens in most browsers. That if an alert has come up, you first have to click on OK or cancel or whatever it is before you can go back to the page and make any changes, right? You cannot interact with the page until that so-called pop-up that came up has been removed. So this such a kind of secondary windows are known as modal windows, because these windows are I mean these windows cannot be basically ignored, right? You cannot ignore these windows and continue working. You have to interact with them first, and only then can you interact with the base, the parent. The other type of windows are more like non-modal windows, so you can keep them open or you can minimize them. You can basically interact with them kind of independently. When you close the main window, even they are closed. So I don't know how many of you have seen these kind of things in certain Windows help systems, where if you click on help, a new window will come up for help, and it is independent of the actual window where you were working in, right? So you can minimize it, close it, maximize it, whatever you want, and then you can help, you can continue to use the main window. So these kind of windows are known as non-modal windows, which allow you to interact with the main window even though they are open. So whether you want a modal window or a non-modal secondary window, that is up to you. It depends on the kind of use case you have for it. By the way, modal windows are more common. So anyhow, so now whenever you create a window, there are going to be some widgets in it. A typical widget is essentially a UI element with which user interacts with. For example, a button. A button is the most common type of widget that you probably see. It's a clickable widget, and whenever you click on a button, you assume that something is going to happen. Similarly, a text box is a single line text input widget where you can go and type, let us say, something like your name or your roll number. A text area is essentially a text box but with multiple lines. Okay, so certain UI toolkits allow you to create multiple line text boxes. They are also known as text area. And there are scroll bars, which with the help of which you can scroll the content in case the content's height or width is more than the main window's height or width. So these are the things that you, and then there are drop down lists and check boxes and radio boxes. They are all there. They are all widgets. Okay, and you add these widgets to the main window. And there are another type of widgets that you might often use. These are known as container widgets. Container widgets actually group multiple widgets together into one. And why would you like to do that? You like to do that because you would probably want to use a different layouting strategy for certain components. So you just group them together into a widget and then lay them out differently. So what exactly is this layout strategy? So a layout strategy essentially decides how your elements within the container are going to be displayed. And another crucial aspect of a layout strategy is that it decides how do your widgets, resize themselves and maybe move themselves whenever there is a change in the size of their container. The container could be the main window directly, or it could be a containing widget. So the question is, why would there be a change in their size? It's because as users, you are often allowed to shrink or expand a window that is open on your screen, right? So if you shrink the screen, if you shrink the window, what should happen with the buttons and text boxes and so on? If you expand the window, what should happen with these widgets? So all these decisions are supposed to be taken up by a layout strategy. And so you can understand how important these layout strategies are. One of the most common layouting strategy is known as the grid layout. In a grid layout, you lay out widgets in terms of fixed size grids. Okay, so these grids are of fixed size, and whenever there is a change in the container size, the new size, whatever it is equally distributed among all the elements, among all the widgets. Okay, so let me give you an example. Assume that this is a container or a main window, and I'm using a 2 cross 2 grid. So this means that it can place 4 components in this container, one here, one here, one here, and one here, something like this. So after creating a grid layout, if you add 4 different components to it, this is how it will look like. This, by the way, can also be another containing widget. So in a grid layout, if you stretch or shrink this particular container, the space, the relative the space that each of these widgets are going to take is going to be exactly the same. Okay, I'll just show it to you when I show you the Qt examples. By the way, the spacing between these elements, usually that is configurable, but often the default is 0. So in that case, if you use grid layout, you will see 4 widgets tightly, packed with each other. If you want to segregate them, you need to use some padding. Now, the most important aspect of building any GUI application is to understand the programming model that is used to build these applications. The programming model actually is event driven programming. Okay, so I'll give you a simple example. If I open up PowerPoint, a Microsoft PowerPoint in my laptop, and I just leave it there, I don't do anything with it, right? So what will happen? There is really no computation going on. Maybe some basic computation, but nothing really is happening, right? PowerPoint expects me to do something. It expects me to create a new slide. It expects me to add some text to it. It expects me to add images to it. So on and so forth. So in any window application, that is exactly how programming is done. You are going to expect the user to do something, to perform some kind of actions which are going to give rise to UI events. So a UI event could be as simple as as simple as moving my mouse in an area. So this whatever I'm doing right now is also a UI event, or it could be as complex as someone dragging something from another window and putting it in this window. So all these things are example of UI events. And whenever you build a GUI application, what you do is you provide event handlers. Okay, so a piece of code which is going to be executed whenever a particular event happens. Okay, so for instance, if you want to make your button useful, you have to provide a handler for its click event. Okay, so clicking of the button is a type of an event, and you are allowed to execute some code whenever this particular event is whenever this particular event occurs. So there has to be a mechanism to figure out that an event has occurred. This is done by your UI toolkit or your UI library, and then you are responsible for providing code that will be executed whenever this particular event occurs. Some other examples of UI events are, let us say, typing of a key. That is also considered a UI event, or minimizing the main window. This is also considered a UI event. And in general, you can provide handlers for all these things, right? Then there's just one more thing. There are two special types of widgets that many toolkits provide by default. One is the menu bar. So it is a bar that is on top of your window, right below the title bar, and it contains menus. Okay, in a menu bar you have multiple menus, and each menu can have multiple items. So for example, the example of menus are file, edit, help, so on and so forth. And the examples of menu items are new, open, save as, exit. All these things are examples of menu items. So usually most of the UI toolkits provide a straightforward support for adding or using an existing uh, 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 menu bar in your application. Another bar that is used often in most applications is the taskbar. So in the taskbar you put cute icons, and then they are like the shortcuts for going to a menu, something like this, that uh, this is the menu, and then this is the taskbar. It is also known as status bar or other bar. So basically some bar where you can put these kind of icons. So we are going to see how a basic window application could be created using Qt. The lecture is already there. You can have a look at it, but I'll also show it to you today. But you have to go and create an account for yourself. You have to download the online installer. The OpenGL may or may not be installed on your system. I tried it on Ubuntu 21.04, and it was not working. So this, there is a, there is a command which is there to install OpenGL. But once you are done with it, and once you have a Qt available with you, it is really cool to work with it. Okay, any questions? Otherwise, we'll see some Qt now. Okay, so let us see some Qt now. I hope you guys can see my virtual machine now. So the installation part and all, you can have a look at the slides, and you can figure out what exactly to install. You can also see the lecture. So I'm going to use what is known as the Qt creator. This is what comes up when you use the Qt creator. I have a project already created here. It will take some time. Okay, so within this project, the first thing you can see is that there are header there is there are there is a place to put your header files. These headers look very similar to how we define it, right? You start with an if and def and define, and then you keep on, then you provide the class definitions, the class declarations. Then you also have the sources folder, where you provide the definitions for those those declarations that you made in the header file. And then you have this main.cpp, where you have you have the actual application which gets executed. You can see there is a main window, and there is only just one method that is being called here, main window dot show. And now let us go here. This is the code for the actual application. That application code comes here. It's C++ code. And if you want to see how your current UI looks like, you can go to the forms section and then click on main window.ui. So this is a typical scenario. You can see that there are widgets here. This is a label. If you want to change anything associated with any widget, on the right side you can see a property editor at the bottom. Okay, so it has so many properties that you can edit. So for example, if I want to make this labels text as aligned to left instead of aligning center, let us say I want to do that, something like this. I can go here, and then you can see what is the alignment part here. Horizontal is H center, so you can actually go and make it left. Now you can see that it is actually left aligned. I could change it back to centrally aligned. So this property editor, you can basically drag and drop drag and drop widgets here. So for example, you just drag this and put it here. So it is possible to do a drag and drop. But what is really important is that you should understand how the properties inspector work. Okay, if you know this, then you can easily change the properties of whatever you want to. Now, talking about those event handlers, one way to do that, they are called slots in Qt. So you basically say go to slot, and then you can choose which of the slots, which of the events are you talking about. And then in that case, you can go and see, I have already created an event handler for this. This is it. On click on the me button, or whatever, on click me button, this is what happens. I'm going to display a message first on the standard output, and then this label, the label that is there on top of that button, the text shown by that label can also be changed. So let me run this. It'll ask me to save all. I'll just not save it for now, because I probably added some new widget. So this is how it looks like. And let me bring it here. If I click here, you can see the message that I had put. it is now coming here, not by itself, but whenever I click it. And the text of the label has also been changed. Okay, and now let us go. This is the menu, by the way. You can access the menu here. If you want to add more items, you can do that, or you can add a new menu itself. You can do that as well. Now, something about layouting. So what you can see here are examples of three layouts. Okay, this is the horizontal layout, this is the vertical layout, and this is the grid layout. So in horizontal layout, whenever you keep on adding more elements, it is just added as if these elements are in a row. That is the idea. Okay, similarly, when you add something to a vertical layout, something like this, the new element is basically added as part of a single column, right? This is the idea of a vertical layout. And if you want to use that grid layout, this is how it is. It is a 2x2 grid. Now if you want to see how layouts are such a crucial thing, see this, for example. How do I select it? So if I stretch it, the buttons stretch with me, right? I mean, with this area. That is the idea of using a layout. Okay, with the help of layout, you can actually predict how would a particular widget look like if the screen size or the container size gets changed. So and this is the same with grid layout, you can see. uh, okay, all the elements will always remain of the same size. That is the part with grid layout. Okay, any other things that we can cover? I mean, I'm pretty sure you guys would not have yet seen the lecture. But this is it from my side about Qt. And by the way, yeah, one more thing. If you see how all these things happen, so just a minute. Mm. I want to see how all these things happen. See, Qt projects, first project here. Okay, not here. Where will it be? Mm, Here, right? So here, if you can see that there is a temporary folder. If you go inside this, you'll see some .o files. Okay, so if you've been following the examples that I have given in week 6, week 7, they all used .o object files and then linked them together to make an executable. And here is the make file. That is why I've been forcing you guys to use make files, because make files make your lives easier. So you can see how many things are there. If you want to compile all this manually, just think about the amount of effort that will be required, right? So there is a make file as well. And in fact, you can do something like this: make clean, and then you can say make, and it will actually create the executable by using the Qt libraries. Okay, that is why the size might actually be slightly higher, because the Qt libraries are also being included. Should not take so much time. Anyhow, so at the end, the executable, okay, it is there. This is the executable. If you run this, same thing will come up here. So the idea is that Qt is going to create these executables for you, and these executables can be created across platforms. So you keep the same source code, and you build it on Linux, and you have a native Linux window application. You build it on Windows, and you have a native Windows application, so on and so forth. It also works with Android and iOS, if I'm not wrong. Okay, any questions?
The Qt creator is a IDE or Qt is a something.
Yeah, so basically, first of all, Qt is a library. Okay, and the Qt creator is an IDE that helps you use the Qt library with the help of a drag and drop editor. So in theory, you can of course use just a typical text editor and build your applications using Qt. It is just easier if you use the Qt creator. But it is not necessary. Qt is different and Qt creator is different.
Okay.
But it's a very cool thing, guys. You can, if I'm not wrong, you can create I mean, since I saw this, when was it that I worked on it? 2000 2007 or so. So in the past 13 14 years, Qt has grown exponentially. Today you can use it to create UIs on Android, if I'm not wrong, on iOS also, I guess, Windows, Linux, Mac. So they have versions for everything. They have a commercial version, they have an open source version, and the coding is done in C++. So it's up to you. You know, if you find C++ to be your primary language in which you are going to work into, then maybe Qt is going to be a very nice application for you, a very nice a very nice application designer for you. You can use it to make some cool window applications. Okay, any other queries? We do have some time left. So please have a look at Qt and try to create some good GUIs. The reason I covered this is because this is something that might interest a number of people, right? I mean, creating window applications is something that seems exciting. You know, working in the field of console and just, black background, white text. Sometimes it gets boring, but the moment you say I can build window applications, okay, you are now on a whole new level of programming. So this is why I decided to include this within the course. And please see if you can use Qt to build something interesting and meaningful. Okay, and if there are no questions, we can break now. Okay, guys, so we'll meet tomorrow on the regular lecture slot. Bye.